So we're asked to differentiate these problems. So I'll go ahead and start by showing the derivatives that I'm going to be using. So these are the derivatives I will be using. A pattern from these three derivatives is that if it starts with the c, then the derivative is going to be negative. Yeah. Okay. Moving on. It's going to be 3 cosine x plus 2 sine x. And that right there is our answer. Next, derivative of tan is secant squared x, and then minus 4 cosine x. And that right there is our answer. So here, it's going to be 2x, and then the derivative of cotangent x is negative cosecant squared. For this one, let's see, it's going to be, so when you're asked to like differentiate something like 5 secant x, the derivative of secant x is secant x times tan x, but because there's a constant here, you can just take this out. So like so, and then it would be 5 like that. And then you can go ahead and distribute if you want. Moving on, it's going to be 2 secant x tan x. Derivative of negative cosecant is going to be negative cosecant x times cotangent x. So positive. And that right there is our answer. For this one, we're going to have to use a product rule. So and that's our answer. And then for this one, we're going to have to do product rule again. And that's our answer. So this is going to be product rule again. So derivative of secant x is secant x tan x times tan x plus. And then derivative of tan x is secant squared x. And then we can simplify this using some trig identities. Actually, no. That's the max. So this one is also product rule. Derivative of sine is cosine x. And then derivative of cosine x is negative sine. So I just went ahead and put the negative there. So then we have cosine x minus, or cosine squared x minus sine squared x. And this is a double angle identity. All right, moving on. I'm going to go ahead and start by distributing sine x. And I'm going to go ahead and differentiate. So this right here is just from this term. I'm going to start differentiating this right here. Well, if we found that the derivative of sine x cosine x is just cosine x minus sine x, and I'm just going to go ahead and plug it in. Cosine squared x minus, yeah. And then from here, this is also a trig identity as well. Yep. Oh, no, it's not. Okay, but we did find that uh, this was a double angle identity, so I'll go ahead and simplify that. And that's our answer. So for this one, um, let's go ahead and start by distributing. And then let's differentiate. So that would be e to the x 10x. And let's go ahead and factor out an e to the x. Um, oh, I need to distribute the negative. That's what it is. So then I'll factor out the e to the x. And then there's an identity. And that identity, I'll write it here, is 1 plus tan squared x equals secant squared x. So this right here is right there, secant squared x minus 1. So let's go ahead and substitute that in. And then this right here is our answer. All right, moving on. So this is going to be the chain rule because this is equivalent to this. So equals negative 2 sine x cosine x, which is a double angle formula. Sine x. And then I think chain rule is in the next chapter, so I'll also go ahead and just solve this a second way. Cosine squared is the same as cosine x times cosine x. So this would be product rule. That would be sine x minus cosine x sine x, which is equivalent. There we go. So that's our answer, or this, either one. All right, moving on. So then it's going to be e to the x sine x plus e to the x cosine x minus sine x. And that's our answer right there. All right, thank you for watching the first part.